Atlas, thank you very much for inviting me here today. We've just had a series of 3 conferences in Brisbane, Sydney and Melbourne, taking a look at what is happening with BIM in Australia, and we've had extraordinary response, and I'm going to talk about that in quite some detail. First though, however, what is the composition of our audience? So architects, engineers, QS, constructor, builder, supplier, someone I've missed? No? So primarily architects and a little smattering of others. At our conference, a large number of builders for the first time. It's the first time they've actually seen to make a move, so I think we've got some things happening. So there have been many studies. You've probably seen all of these reports. This is one by NBS in the UK, very interesting report. They're a specification organisation. They've suddenly realised that BIM gives them a new opportunity to manage information over the life cycle of a project. Because a specification is just a very detailed description at a stage of the job, and what happens before it, what are the requirements. And so they're coming up with some extraordinarily innovative ideas, and I think you'll see specification bodies suddenly morph into a much different organisation. But this is the report that I would like you all to focus on today. This arose at a meeting of BIM in Canberra, the Built Environment Meets Parliament, which is hosted by the Institute of Architects, PIA, ACA, or Consult Australia, and a couple of others, probably Council of Australia. And we were asked by the Commonwealth Department of Industry, Innovation, Science and Research if we were going to adopt BIM in Australia, what would be the impact? What would it cost the government? But what was the actual impact? So we commissioned Allen Consulting. So buildingSMART led a group of people that commissioned Allen Consulting in Sydney to undertake just such a study. And the study was absolutely emphatic. There's an enormous productivity benefit. The benefit is so big, it's comparable to some major transformations of ports, the steam engine technology of the late 18th century, 19th century, and it's so good, it's a no-brainer. It is literally a no-brainer. The benefits and savings that could come from it are extraordinary. And the Minister for the department, Minister Kim Carr, has endorsed this very strongly, because the results of this study were presented to the Built Environment Industry Innovation Council. That was a council of industry representatives from the construction sector. Sue Holliday is the chairwoman of that group. And of the 10 recommendations, number 2 was BIM. And BIM was recommended because it would be a productivity bonus. It would actually give us a paradigm shift in the construction sector. But secondly, it gives a leadership in the industry. However, if we think that BIM is so good, exactly why are we adopting it? What is the purpose of adopting it? It's not because it's an interesting technology. That can't be the reason. I believe it should be because we're trying to develop a sustainable built environment. That must be our target. That's what our role in industry is, to improve the many desperate situations that we have already. If we're going to have a sustainable built environment, isn't it time that we looked at this from a national point of view? Okay, some major firms and some early adopters have started to get and use it strongly. You see some construction companies starting to use it as well. We see it in other arms. We see AMCA, the Australian, the Air Conditioning Manufacturers Association of Australia. They have prepared a proposal for the supply chain integration. So from the mechanical design engineer right down to the laser cutting fabrication in the duct factory, they're proposing an integration of the modelling and all of the supply chain involved in it, in a similar way that's in the steel construction sector already. But why are we going to, is this going to be a national benefit, or is it just going to be through one organisation or one company or something like that. And we've got to be clear that when we adopted 2D CAD in the very late 80s and the early 90s, it was quite a different situation. We were naive about computing. We had no knowledge about 2D CAD, as it was then called, and everyone just did it because it was available. Computing was brand new, but today we've got very mature business systems that allow us to do it. But let's look at what's happened in the 2D CAD world. Today, after 20 years, there are no common guidelines. There's not a single document here in Australia or worldwide that would be considered to be the reference document that would guide us in using 2D CAD. There's an actual decline in documentation quality. Engineers Australia in Queensland in 2005, getting it right first time study, identified all of these problems. Poor briefing, poor use of technology, declining documentation quality, and our BIM study report identifies that in contrast to almost every other sector of the economy, the construction economy productivity is dropping. This is an economic statistic, not just our own internal quality. So we've got to do something to rescue that. No consensus in either industry or government. If you approached a government agency and said you had some matter about 2D CAD, most people would not have the slightest idea what you're talking about. And yet government is responsible for 40% of the building stock in Australia. They are one of the largest procurers of complex buildings in the health sector, for example, and in defence. So there's a very big self-interest of government to ensure that these things improve. Finally, no process improvement. If there was a single big criticism of the construction sector, we don't do process. We invented every project, every time, in a different way. You couldn't rely on anything. A different consultant will send a different set of drawings in a different method. How can you possibly get productivity and efficiency and quality out of a system that no one has even the slightest simple guidelines for use? So there are some, although the benefits of BIM are enormous, and I encourage you to read the report and see some of the things that are there. And anyway, most of you are here probably because you already recognise those benefits. The ability to visualise and explain to your clients is a starting line, and it's common in whatever technology you're taking out of BIM. And from that flows lots of other things. The current one today is clash detection, the low-hanging fruit. Why is clash detection so good? It takes out a significant portion of risk from the actual construction process. So some of the big builders are pushing it hard because they see an economic and quality benefit for them. But what's your benefit as designers if I treat you all as designers rather than further down the life cycle? Where do you get your benefit from? And soon we're going to come into a major set of roadblocks. These are a lot of topics that we don't have at the moment. We have no model building protocols. Do we even know what we mean by model building protocols? What is a well-built BIM model? Do we have a definition of that? What do we mean by it? Is it a well-built model to suit a client at the end of the delivery? Or is it a well-built model to suit analysis during the design phase? Or is it a well-built model that a contractor can take a 4D or 5D version of it? There's an argument that architects and engineers cannot deliver a building model to a contractor because it's in the wrong form. So what do we mean by that? What are these concepts called levels of detail? We have a lack of BIM object libraries. That has to be the biggest single barrier emerging in the industry. How can you do analysis, integrated automated analysis, if you don't have the property data of the objects in your BIM model? And at the moment, you can't go to the product manufacturers and get that BIM data. You'll go to a couple of them and they're just skimming on the edges. At the moment, the whole profession is inventing their BIM library data from scratch. And the tragedy with that is that none of those libraries are the same, And the other tragedy is that the data that is being put in them by those project teams or those organisations or those specialist BIM resources, probably the most technically competent specialist BIM resources who shouldn't be doing it, but are the only people capable of it, there is no integration or coordination of those properties. So we still, after all that work, we're left with 27 versions of the same thing. So we're not making much progress. Now there are lots of other things that I'm going to explain in a bit more detail down the track. For those who know me, know that I've been in health for a long time. So this is the Health Building Guidelines document. You can go on the web, it's easy, it's accessible. You want to see a particular detailed design for a room, there we are, there it is. And eventually you can do this sort of typical documentation of that space. But if we were to show that to a nursing unit manager or a medical expert or a manager in a hospital, they don't understand this in detail. We've done a project, actually we did it with Atlas. Atlas were the sponsors of this project, where the client came to us and said, I've got all this 2D documentation of the hospital. I want to be assured that what is on those drawings is actually what we've asked for. And the only way I think we can do that is to present a high quality 3D model. So we did exactly that. We modelled 7 specialist areas in the hospital, modelled them, presented them in a high quality graphical rendering, animated graphical rendering. And he said, well, that's better. But the nursing staff said, but all those things in that room are not right. And heavens, all sorts of things are wrong. So there was the first great value of BIM. The high quality rendered model of it was so much more powerful than these 2D drawings. These drawings are not for lay people to understand the scope of design. These are for technical people to build it. But even the technical people who want to build this, it isn't the best way to do it. BIM is better.